Thank you for joining us this morning. Up now, we have 3D printing in the digital factory. I'll introduce you now to Brett Klisch. Brett?
Good morning. Welcome. Yeah, this is early. For the third day of the show, this is quite early, and I see all the smiles agreeing that you'd rather be still in your hotel room. But thank you for coming out. My name is Brett Klisch. I run Peru Meridian Studios, a service company that designs, develops, and manufactures products in the toy and consumer good industry. I'm the founder of this program in 2003. Yeah, we're going to be talking about 3D printing, and we're going to start with a basic simple primer on just what it is for anyone that's newbies, and then we're going to go on to a little more fine detail. And my co-host is Christina Perla. Just talking to it. Okay, start working.
Hey everyone, thanks for being here so early. It's quite early for myself as well. I'm Christina Perla. I'm the co-founder and CEO of Makelab. We're located right here in New York, in Brooklyn. We 3D print a lot of parts for a lot of consumer brands, toy brands, independent toy creators. We work with a number of design agencies as well, so if you're familiar with the landscape, like Pensa, Doris Dev, Tomorrowland. We work with all of those, as well as some brands like Quip, Estee Lauder, Peloton, BarkBox. Yeah.
Okay, so how many people have actually used 3D printing? Okay. Who would say they're an expert? Okay. No. Moderate use of it, general overview that you know what's going on. Okay. And I'm saying the rest are pretty much newbies then. Okay, good. I'm glad we're starting simply. So there's multiple different definitions of the technology on how 3D printings work, and we're going to go through the three top ones to start with. So they're called stereolithography, or SLA. Everything is shortened to, what's that? So what would it be called? Not onomatopoeia.
Acronyms.
Acronyms. Thank you. Then FDM, fused deposit material, and then multi-jet fusion, or MJF. So if we say the shorthand, now you know what they are. So you want to take SLA?
So first up is SLA. This is also referred to as resin printing. Basically, the way it works, as shown in the graphic, there is a build plate that comes down from the top. It gets submerged into a bath of resin, which is the 3D printed material. And from the bottom, a laser comes up and cures each layer in each detail layer by layer. And so you'll see, if you see a sped up version of SLA resin printing, what you'll see is something growing out of a bath, which is pretty cool. I think this video should be playing. Is it gonna? Yeah. So what this is really great for is concept modeling. So what results with the resin printing, because it uses lasers, is you get a very fine surface finish. People have referred to it or compared it to injection molding in the past. You can get super smooth things that look like final plastic materials. So anyone that has been an independent creator doing some sort of collectible or character modeling or toy design, we usually refer them over to resin printing because of the resolution, because it's able to capture those fine details. One of the caveats, though, of resin printing, and you'll see it in this video, is the need for support structures, kind of like scaffolding. So the only thing with support structures is because it's required to print, as you're post-processing and taking it, taking it out of the printer and getting it ready for its final use, you need to clip and lightly sand away the nibs and scarring left from the support structures. So while it can be really precise in some areas, you do have to be mindful of where you're placing those supports. So we did a project with Chick-fil-A, for example. They had a pop-up shop in 2019. It was something for the holidays. And they were printing all these maybe 6-inch characters, all Christmas and holiday themed. we were very careful not to place the support structures on the hands because that is difficult to sand and would take away from the quality. And so for a visual model, you want to be able to see the hands of the character that you're printing. And so we were very mindful of that. And we did the same for a DreamWorks project for Gabby's dollhouse.
If you'd like to see a lot of SLA parts, not this hall, the next hall, I think the C hall, the first 2 aisles is collectibles, like action figures, the statues. Those, most all of them will be done on a newer version of the printer that you're seeing in this video. So if you want to see this in action, I know there's a lot of prototypes because I know a lot of those companies. So the next one is called FDM, Fused Deposited Modeling. What it is, it's a glorified hot glue gun. It is a print head that, actually, just go to the video. So the thing that's moving is a print head that is pretty much a little nozzle that heats up and squirts ABS, PET, PLA, a host of different materials through it, depending what your characteristics you want. And then the motors move it, and the X and Y axis builds a layer, and then either the bed goes down or the print head goes up, and it does another, layer by layer by layer. All these technologies are stratified, all layers. This one, much cheaper. The materials, resin printing is expensive. FDM can be cheaper, depending on your material. Usual material that we just crank through is PLA. A little delicate, but it's great for iterative prototype and smooth things. If I'm doing this coffee cup lid, which we actually just did a bunch of, we just crank them and crank them and crank them on FDM because we'd get it done in 20 minutes. And we don't mind if it breaks because they're very delicate. We have very robust versions of these machines that will print in ABS, and some of those can be pretty much indestructible. So they're very good simulations of your final production material. So it has different uses. A lot of places, like Christina's company, my shop, we have these machines side by side. We'll use them on the same project. FDM will sometimes be the first one because it's quick and cheap. We do iterations, and then we move on to the SLA for really nice finishes, a beautiful, beautiful piece. But sometimes FDM will be the final thing because we want the strong material. So those are the differences with those two. And now we're going on to one that I quite don't understand. Christine is, I think, the first place in New York that is offering this.
Yeah, so this is one of my favorites. So this is a little bit higher on the price point scale, but this is called multi-jet fusion. So this is a technology that was invented by HP, like the paper printers, and basically it's unlike the two previous technologies that we talked about. So you have a build chamber and a very, very thin layer of fine powder called nylon PA12 is laid down. And then after it's laid down, you have kind of like an inkjet head that deposits binder fluid. So it binds the powder layer by layer. And so this is really cool because, like I was talking about in SLA and like you need with FDM, you don't need supports in this. Any powder that's not being, that's not being bound together by the binder fluid, that acts as support itself. So it's self-supporting. And after they call it excavating. You excavate the part out of the chamber of powder, and that's what you have. So you don't have to sand. You don't have to worry about support structures. You don't have to worry about how it's being oriented and if I want the hand of a model to print. It just prints, which is great. The one caveat is you have to be mindful of trapped powder. So if you're printing a ball, for example, you wouldn't want all that powder inside of that hollow ball to be printed. So you'd want to model in an escape hole, a drainage hole per se. That's one thing to be mindful of. And the other thing to be mindful of is if you have, this is more so for robotics and components of, complex assemblies. If you have a part with a long channel, it might be really difficult to blow the powder out with a sandblaster or a bead blaster. And so, but other than those two design challenges, it pretty much just prints as is. And what you get is a slightly grainy texture. I have some samples that we can pass around later. But you get a slightly grainy texture. It's very consistent. So it really does mimic kind of like an end-use plastic part. It's extremely strong. It's great for being outdoors. We did a large project for the shed over on the High Line that I still think is there today. It was fixtures for the garage door opening. And we printed probably about 100 different parts. And it just turned out, it was no drama. It was great. This material can also be dyed. So you can dye it to different colors. However, you cannot make it lighter. So it is a gray in color naturally. If you want to dye it, it's going to have to be a darker hue. So you can dye it black, dark blue. You cannot dye it neon. You cannot dye it like a bright yellow. You cannot dye it white, unfortunately. But it can also be vapor smooth. So if the grainy texture is an issue, what you can do is you can vapor smooth it to really kind of be like the SLA parts. It's just going to be a little bit more in cost.
Great. So now that we went through the 3D, the technologies we're going to talk about, we're going to talk about some of their uses. So the first slide is a very simple example of FDM because it's showing many, many versions of one product in its iterations. This is 4 different iterations. All do the same thing. My studio did this. Not going to tell you what it is, unfortunately. It kind of looks like an abstraction now, but the colored ones are earlier because we made them, sanded them, painted them, tested them, found out what didn't work, and we made another. These are on the FDM technology, and they're done in ABS, which is the higher scale of it. So each completed version probably costs under $20. Outside of the $20,000 printer we have sitting there, the material was like $20. So per piece is pretty cheap. But these I can drop. These, if they fall off the table, and they did, they would just bounce because it's ABS. If they weren't done in the PLA, which is a softer one, and less shatter resistant, they would shatter. So this is good, so we want to do it. Sometimes we'll look at a piece, go, and literally throw it away in 2 seconds, make a little teeny 1 millimeter tweak, and print again. So it's an affordable way to just keep iterating and iterating and iterating, and then it does give us very nice, robust, because this is a game that will kind of get abused. It's for kids and adults. It uses marbles, it moves, it falls, and the blue one is like 3.5 years old, and it's got some dents and bangs, but still works. Now this is an SLA. So one nice thing about SLA now, in the past 10 years, the technology has not changed that much. The machines used to go $100,000 to $1 million, pretty much because companies had patents on them, and only they can make these machines. As soon as the patents went out, they started making desktop machines. Like these things were the size of a refrigerator and bigger, because they are able to do it to justify how expensive they are. They still make machines that expensive, but those are like the industrial machines. Those are the ones GM is using. The desktop machines, which can be this by this, are the ones that we use every day, all day, in and out. The great thing about the change in tech is material science. You can reproduce, like 40 different materials now and then Formlabs alone, and that's just one company, go from a nice strong ABS to a polypropylene that has a little bit of flexibility so it won't snap, that if it bends, it's all nice. This piece has 1, 2, 3, 4, 5 different materials. On your left is a prototype. On the right is the finished piece. The center core with the screw on it was done out of a very, very strong material that it's only about half an inch thick, but it would take me a lot of work to snap it in half. So that's the core of the piece, reflecting, which I think was the polypropylene final. The clear is clear. We can print in clear material, which in the initial video, those parts were clear. If you spend enough time to sand it and polish it and finish it right, they can be optically clear. They use this for lenses and refractors all the time. The milky color, that has a little bit of flexibility. So that, it's not still plastic, but it has a rubber quality to it, when it can bend and flex, so it'll simulate the vinyl final pieces. So since we designed it, we knew what we wanted the final pieces to be, so we can make our choices with the prototype to make this as close to the finished piece as possible. And it surprised people. It surprised us. We're geeks. We love this stuff. So when this was done, we were, smiling for days that we got this so close to what we wanted it to look like. And then what you will mostly see here, things that you would notice as being a 3D print, is a lot of character stuff. All the action figures, all these statues right over here in the collectible area. Like, this is a 3D printed part that we painted, over 10 years ago. But I could use it here because it was shown 10 years ago, and it was made to go on display. Because it says Soleil, it's a little delicate, so it goes on a shelf in a glass case for a company to show off. You can see on your left is the 3D file. That's in the 3D printing software, so you can see all the detail, and that it's all there in the final piece. All the little cut negative shapes in the teeth, the sharp edges around the lips, they all get reproduced in this material nowadays. And I have this thing this big, I have it this big. The scale, we can just scale up and down because size is relative when it comes to an original digital file. And that is more of the traditional uses that we've been doing. I've been doing this for at least 25 years for those purposes. As the tech has been getting better, I've been doing in the industry. So now we're going to be going through more of what it's doing now. Some are kind of applicable, some aren't. So we're going to go through MedTech. I am going to use a very specific example because it's surprisingly good for right now. Right now, 3D printed hearing aids. I just got fitted for 3D printed hearing aids. They scan your ear and they 3D print them to fit perfectly in your ear so you get no bleed on sound and whatnot, and so they're comfortable. I just had a root canal. They scanned my teeth, and instead of sculpting a crown out of dental acrylic, they're printing it on the same exact machines we have, just with a ceramic biocompatible material. So one of them is going in my mouth in like 2 weeks. 3D printed insoles. I've got weird shaped feet. I would go get Dr. Scholl's from Rite Aid. They never, ever, ever fit right. So went to a doctor and like, oh, we can do this now. And I'm like, shit, I can print one of these at my studio. But you need a real doctor to do all the measurements right. And this is something this is an area that's growing a lot of money in it. It's going up and getting better very, very, very fast, to where stuff like this is going to be available very soon to everyone. And the most interesting one is 3D printed vertebral interbody. Bottom of my spine is now titanium. I was in an accident and I broke my back. So they replaced my lowest vertebrae with titanium. So I've got titanium screws, a titanium fixture, like what you're seeing right there, and titanium rods holding my spine together. So strangely enough, this has been my profession for about a quarter century now, and I'm becoming closer and closer and closer to RoboCop every day. Kind of exciting. It hurts sometimes, but yeah, it's a very simple exercise to show you where this comes into play into your daily life. Every phone that you're holding and taking pictures of right now, which most of you are, was designed and developed on 3D printers or CNC mills to actually make them. The frame of the next generation of 15 is used in another technique called CNC milling, which takes away material, but it's all used from that. So now we go into more of Christina's.
Yeah. Fixtures and jigs. So if you think about a manufacturing floor, you have all this custom tooling in the manufacturing line. You have machines and fixtures that grab components, that put them together, that screw components together, that snap fit together, tension fit together, all you can think of. But if you think about all the different types of products in the world, everything is a different shape, everything's a different size, different material. So how does a manufacturing plant with a set of machines to manufacture, how do they make it work for such varied products? Well, one thing that's been really highlighted in the 3D printing additive manufacturing world is the ability to design, print, create, manufacture custom jigs for the manufacturing tools themselves. So if you have something that, a product that's a little bit larger, or something that's circular in shape rather than square in shape, well, now it's not an issue. You don't have to buy a new machine. You don't have to get it CNC'd. You can quickly print it in a material that's super accessible. You can use a service like Makelab. We see this a lot. You can get your own 3D printers and do it yourself. But either way, it just makes it for a much more agile production workflow. And so one example of this is we were printing parts for a factory in Puerto Rico. And they were doing some sort of grabber. So we printed male-female components, and we printed about 3,000 of each, all in a material that was able to simulate polypropylene, which is really useful because that material is very durable. It's not going to break. It's not going to shatter. It has a bit of flex, and so it was just right for what that company needed. And so with this, you're able to cut down on costs. You're able to move a little faster when it comes to, tooling and fixture design, when you hit the manufacturing stage, and things just become a little bit easier. Another example is complex products. So this is a little bit more applicable for aerospace industries, automotive, and robotics and drones mostly. But if you think about all the different components that make up each of those complex assemblies, like if you think about a car motor, if you think about a robotics, like a robot, think of Boston Dynamics. There are a ton of custom parts that need to be separated because of the way that they're manufactured. So if you think about traditional injection mold making, or CNC even, there are a lot of constraints in each of those technologies that would force you to divide a function into multiple parts, into a multi-part assembly. However, with 3D printing, what you can do is now you can combine a lot of those because it's so freeing geometrically. You can print weird shapes. You don't have to worry about undercuts. You don't have to worry about things that you would have to worry about with other manufacturing methods. A great example of this is a company called Ocado. They're out in Europe. They're really, really big in groceries. And so you would think, what does this have to do with additive manufacturing and 3D printing? Well, it's an automated grocery delivery service, biggest in Europe, kind of like what we have here with Amazon groceries, or maybe, Amazon groceries or Amazon Fresh. They designed and innovated on an entire storage system that is below the floor of their factory, and up top they have all these robots that are not only aware of each other, but they pick the groceries and pack them so they can get fast delivery. And so if you think about how this would work, you have a grid of robots sitting on top of food. So one major thing is you need those robots to be light, agile, fast, easily replaced, and easily iterated on. So actually what they did was they created a robot that's, I believe, 75% 3D printed, which is amazing. It looks unlike any other robot because you're able to do crazy geometries, because a lot of components are combined, but the entire thing is so much lighter than if you were to make it out of metal or even another material. And so that's a great use case.
Yeah, kind of like how people can 3D print drones. Like the mass-produced ones are injection molded, but people that customize them or race them, they design them, and they 3D print the drones that actual fly, and they're robust. They could fly and fall and survive. And they're 3D printed, and they weigh nothing.
And so this is pretty interesting because you can apply lattice in two ways. So similar to the complex products, part of why the robot for Ocado was able to be so light is because you're able to print lattice structures. So instead of having a block of material that you carve away and you can't reach the inside, it's just dead weight, really, in the inside of this solid part of this model, you're able to input lattices because of the 3D printing technologies and their capabilities to make it lighter. And all the excess material in the open space will just fall out, be sandblasted or be blasted out. And so it's really effective in lightweighting parts. But the other side of that is you can really do some really interesting things with simulating foam. So foam is difficult. It requires a mold most of the time, or you have to, crudely cut it or carve it. I've done prototyping with foam in the past as an ID major at Pratt. But what's really cool about 3D printing is if you have a softer material that's slightly elastic, and you're printing out a part with lattice structures, you're really able to simulate different densities of foam. So you see this a lot in end-use products. It's been out in the news. There's a company called Carbon. They make printers and materials. They partnered with Adidas to make shoes on the market that are actually 3D printed. So that's not foam, on the bottom of your shoes, providing you comfort. That's actually 3D printed material, which is very cool. You'll see this more and more in seat cushions. Right now, for sure, at the prototype level, I'm a little unsure whether it's hit commercial use yet. You'll also see this in, especially the prototyping stage of designing things like headsets, headphones. We've seen it a bunch. It's very cool because, again, it can be entirely custom. If you need more density, you have a more dense lattice. If you need something super soft, you have a less dense lattice. So the options are really endless, and it's very, very interesting.
Outside of Manny, does anyone here know how to make a mold or how molds work? Okay, look at this structure. One of the really cool things about this is not a moldable form. You cannot cast this because of all the interlocking little windows that are made. So this is only possible with 3D printing. And anyone, by looking at these images, especially the one on the left, kind of gives it away. What's the inspiration for this structure? I know what it is because I know the guy who made this. Anyone kind of guess what it looks like? Technically, yes. The inside of your bones. Yeah, if you look at the structure of the inside of your bones, that's what this is simulating. And Nolan Kim designed these, and he used that specifically for it and he did this algorithmically. He wrote a program to design all this, and which makes it work surprisingly well. What we're seeing here, this is cutting edge algorithmic design work.
And I have a sample I can pass around as well. It's very squishy, very fun to play with, but you can really feel what we're talking about.
And finally, we're going to go on to something that is very applicable for here. I'm sure a lot of you have seen this. This is Hasbro's selfie series, where you take your iPhone, you take a picture of yourself, you move your head back and forth, and you send it up to them. And a couple weeks or months later, in your mail, you get a little action figure with your head on it. Been something that's been in development for decades. I actually started this in 2008. I did the first one when the material, the hardware cost me about $250,000 just to start this up. Yeah, it lasted about a year. So a couple of years ago, they picked it up with a company called Formlabs, and on the left, you can see the scan of what it looks like when you're doing it. And then on the right, those are the print beds of the machine. They're not on the machine because this is on display on a shelf. So on the right-hand side picture is all the faces. You choose this tonality of your skin, and then they couple all the skin textures that are in that grade on the same print. And they print everyone. They have little labels on them so they know who is who. And the next side is all the hair. Since they're separate colors, they're two parts, and they just click together easily. And this is a bit, they were able to make this automated. So when we did it, it was hand done. It took us like 2 hours to do each person. Why it lasted a very short amount of time. We were way, way, way too early to do this. They spent time to automate the process, so it goes from face to a 3D printable file, and the computer does all the work instead of us sitting there in a 3D program. I wish that was bigger. The face, what really brings it to life, when it prints out, it's sculptural. It's just dimensional, it's monochrome, and they have another printer, a printer that can print on, on a dimensional object. It'll print each piece in a curve, so it takes the file, when you take the picture, it takes your image and makes it as a texture map, and it'll print the texture, the color of your lips, face hair, eyes, and all the details. It'll print it right onto it. So they are not actually hand painted. It's actually kind of freaky because I've painted little stuff little things this small, and it's very hard. They are, if you get to go to Hasbro, they're like 3 blocks south of here. They're not in the building. They are doing this today, and you could go on their website. Can we zoom out to full page? Yes, I don't have a URL, but Google Hasbro Selfie Series, and it's or go on the app, iPhone or Android app, and you can just download it and do it yourself. I think it's $49.99 or $59.99. It's surprisingly cheap for what you get. And that is it. So thank you, and we have 6 minutes left. So do we have questions? And I will be asking my lovely assistant, Manny, can you pass this around? That's seat mic number 1.
Hi, I'm currently a Pratt student, and I was thinking about using SLA printing for a final model, and I was wondering what the post-production for SLA was like, because I know with certain resins, they need to be cured after the print is done, so I was wondering what the process of that is like.
So right out of the printer, you have to put into a bath of isopropyl alcohol. Recommended 99%. And this is because it's coming out of a bath, it's actually situated on the printer just like this. It's going to have a lot of excess liquid and resin that you don't want to touch and get near. So you put it straight into the bath. It's going to wash it away. You let it dry, make sure it's thoroughly dry, and then you're going to put it into the UV curing. And then after that, you should be good to snip off the support structures, and then just lightly sand so that the surface is restored.
And have you ever used castable urethane, like casting plastic? Once you cure it, it works very similar to that. So it's actually pretty easy to use at the end of the day.
Thanks. Hi, good morning. Have you seen anything yet with respect to artificial intelligence converting two-dimensional files to 3D printable files?
Nothing that does it good. I've seen a few things, and truthfully, I don't know if I believe the process, since I'm seeing it online. I don't believe how real it is, even though there are certain things that can algorithmically build something in 3D. But you have photogrammetry, where you take a picture on multiple sides of a piece, and it uses landmarks that the algorithm, which is another word for artificial intelligence, to build that. And that's the standard way that we scan things. So we're technically using AI to take a bunch of pictures to stitch it together to make a 3D model. And we've been using that for decades, like 30 years some odd right by now. So we have been using AI. It's just a big boogeyman of AI right now. People really don't understand what it fully means. We've been using it for a long time.
I think what you can do and what you're going to see in a more finished state, a more reliable state, is something similar to cookie cutters, right? You have something, you have a flat drawing, it's like a top view, and it's just extruded up. I think that can be done fairly quickly, and I don't know about fully like character modeling. That's hard.
Yeah, there's a lot of fake, false reports that the tech world has to hype it up so they get investment into it. So, after the initial fear got over, it's like, oh yeah, this is not there yet. So, next.
Is there any color 3D printers that are affordable?
What's affordable?
Affordable, like I worked in companies where the color 3D printer was like $50K, so something affordable that would be, much on the cheaper side.
So with FDM, multicolor, I'm not sure yet. I think it's still at that price point. But if you want single color, in custom single color, PLA, you can buy it, in custom color. So FDM, you can get a Creality machine for $200, $300 off of Amazon. You're gonna get the it's not the best quality FDM, but it's cheap, it's fast, and it'll work for like a general concept model. Formlabs is a little bit more expensive. It's about $3,500 for a machine. They do have what they call the custom color kit, and they have this hex code, generator. So if you have a brand and you want to match the color, it'll tell you exactly how to mix it. The only thing is you really have to mix it. Like resin is a quite thick and viscous material, so you're literally hand mixing cartridges 1 liter, and you're shaking it for quite a long time. But you are able to do full solid custom colors with resin now, which is very cool.
And next, anyone else? We got some of those experienced people that have to have some questions. We've got 1 minute. No? Okay. Well, thank you for coming out. We'll be available for one-to-one questions. If you're looking for any help on 3D printing services, this is what Makelab does. She's here. She's the pro. And she has brought a lot of samples if you actually want to touch those squishy lattice structures or see the very high-definition pieces that can come off those machines. Christina has brought some of those with her. So thank you very much. Have a great day 3 of the show.
Thank you.